We did find life. Bacteria at the depth of 24,600 feet.
Scientists were very surprised that life could even exist or could be found that deeply.
They discovered a lot of water deep, deep down.
Scientists also found there was a tremendous amount of hydrogen trapped in the rocks, which is completely unexpected.
Beneath the frozen ground of Russia lies a hole so deep it nearly touches the secrets of the Earth itself. Scientists drilled for decades, peeling back layers never meant to be seen, only to uncover things that defied logic. But what they found at the bottom wasn't what anyone expected. Could this hole be holding something the world was never meant to uncover? Let's find out. The Kola Super Deep Borehole. SG3, or the Kola Super Deep Borehole, is one of the most fascinating scientific projects in human history. It's a venture that pushed the boundaries of engineering and human curiosity. Located on Russia's remote Kola Peninsula in the Penski district of Murmansk Oblast, just north of the Arctic Circle and close to the borders of Norway and Finland, it was an ambitious Soviet project designed to uncover the secrets buried deep within the Earth's crust. The drilling began in 1970, led by Soviet geologists and engineers as part of a large-scale scientific program during the Cold War. While the United States had focused on oceanic drilling with projects like Project Moholy, the Soviets chose continental crust as their target, determined to drill deeper than anyone else. Engineers developed advanced drilling rigs capable of handling unprecedented pressures and temperatures, crafting equipment strong enough to withstand challenges that had never been faced before. The borehole was meticulously designed, with the drill bit slowly spiraling deeper year after year, each meter presenting new obstacles. The operation required constant innovation, from modifying drill bits to adjusting techniques to prevent collapse or overheating. The project quickly grew to symbolize Soviet scientific ambition. It was a race not with other countries, but with nature itself. While the United States pursued its own drilling experiments through programs like Project Moholy, the Kola borehole soon surpassed them all, capturing worldwide attention. By 1989, the Soviet team had successfully reached a depth of 12,262 meters, an achievement that remains unmatched today. It was a feat so remarkable that it exceeded the depths of the world's oceans and dwarfed the heights of Earth's tallest mountains combined. Though the effort eventually slowed and came to an end in the early 1990s, the borehole left behind more than just a sealed metal cap on a remote Arctic plain. Built through decades of perseverance by Soviet scientists and engineers, the Kola Super Deep Borehole remains one of the greatest engineering achievements in human history. A monument not to what was found, but to the courage of those who dared to dig into the very heart of the Earth. Now, let's journey even deeper, because what was uncovered at the bottom of the world's deepest hole is far more surprising than anyone ever imagined, and these revelations are guaranteed to leave you in awe. No basalt in sight. When drilling began at the Kola Super Deep Borehole, scientists were eager to confirm long-held geological theories about Earth's crust. According to seismic studies, geologists believed that around 7 kilometers beneath the surface, the solid granite layer would give way to basalt. This transition zone, known as the Conrad discontinuity, was widely accepted as a key boundary in the continental crust. It was thought to mark the place where lighter granite rocks ended and heavier, denser basalt began. For decades, this was what geologists taught and what students learned. But when the drill bit dug deeper and deeper into the Kola Peninsula, expectations quickly unraveled. Instead of finding basalt at the predicted depth, scientists continued to strike granite. The seismic signals that had once been confidently interpreted as basalt turned out to be something else entirely: granite that had undergone intense metamorphosis. In other words, the granite was not transitioning into basalt at all. It was being changed, reshaped by heat and pressure into new forms of rock that still retained its fundamental granite origins. This discovery was a shock. It meant that geologists had misinterpreted seismic data for decades. The reflections in their readings, once believed to be signs of different rock layers were actually transformations within the same granite bed. The textbooks had to be rewritten, and the very way we read seismic signals had to be re-examined. The implications were far-reaching. If granite persisted at such depths, instead of basalt, then Earth's crust was not as simple or uniform as once thought. This hinted at a far more complex structure beneath our feet, one shaped by forces and histories that scientists were only beginning to grasp. What was expected to be a confirmation of theory instead became a humbling reminder. The deeper we go, the less we truly know about the world beneath us. Liquid water under extreme pressure. Another astonishing discovery at the Kola Super Deep Borehole was the presence of liquid water at depths where no one thought it could exist. For decades, scientists assumed that as you travel several kilometers beneath Earth's surface, water would not be able to survive in liquid form. The extreme heat and the solid, tightly packed rock layers were believed to squeeze out any chance of water storage. Yet the drilling revealed something entirely different. When the drill cut into rocks more than 3 kilometers down, it encountered unexpected pockets of water. These were not connected to ordinary groundwater or surface infiltration. Instead, this liquid had been trapped deep inside the crystalline structure of the rocks themselves. Under immense pressure, the rocks had managed to seal and preserve this water for millions, perhaps even billions of years. The water was not simply filling cracks. It existed in microscopic voids, pores, and pathways that had been locked away by surrounding impermeable rock. This suggested that Earth's crust, rather than being a completely dry and rigid environment at great depths, actually held hidden reservoirs of water that had been concealed from human knowledge until this drilling effort. The discovery raised profound questions. If water can exist in such conditions beneath the crust, what role might it play in shaping geological processes? Some scientists proposed that this trapped water could influence earthquakes, mineral formation, and even the movement of magma. It might act as a hidden driver of tectonic activity, slowly releasing and altering the pressure within deep rock layers. More than a scientific puzzle, this finding also sparked curiosity about life itself. If water is found deep below the surface in seemingly inhospitable conditions, could microbial life also exist in such hidden environments? Similar discoveries on Earth have been used as analogies in the search for life on other planets, suggesting that underground water could serve as a cradle for unseen ecosystems. Boiling, drilling mud, brimming with gases. During the Kola Super Deep Borehole project, one of the most surprising moments came not from solid rock, but from the fluid used to cool and stabilize the drill. As the mud circulated back to the surface, scientists noticed it was not returning in the same form. Instead of being plain drilling fluid, it was foaming and bubbling, filled with unexpected gases. To the researchers, it looked as if the mud itself was boiling. The primary gas detected was hydrogen. Its presence in such large amounts was astonishing because deep underground conditions were believed to be far too closed and stable to allow significant gas release. Along with hydrogen, smaller but measurable quantities of helium, nitrogen, and carbon dioxide were also identified. This unusual combination created a caustic mix that no one had predicted. The finding challenged long-standing assumptions that the deep continental crust was dry and chemically inactive. The source of these gases raised even more questions. Hydrogen in particular has intrigued scientists since it can be generated when water reacts with iron-rich minerals under extreme pressure and temperature. This process, known as serpentinization, may have been at work in the rocks that the borehole pierced. Helium, on the other hand, is often produced by the slow radioactive decay of elements deep inside Earth, suggesting that natural nuclear reactions had been quietly shaping the chemistry of the crust for millions of years. Carbon dioxide and nitrogen were perhaps the most thought-provoking discoveries. Some researchers suggested these could point to microbial processes occurring deep underground. If microorganisms were somehow surviving in such an extreme environment, they might be contributing to the unusual gas mixture. This possibility opened new discussions about deep biospheres and the resilience of life far below the surface. The bubbling mud demonstrated that the Earth's interior is far more dynamic than once thought. Instead of a silent, lifeless world of rock, it revealed a hidden environment where chemical reactions, gas generation, and possibly even biological activity were taking place. This finding changed how scientists viewed the deep crust, proving it was not simply a static foundation, but a living, reactive system full of mysteries yet to be understood. Microscopic fossils from an ancient era. Locked inside solid granite, nearly 6 to 7 kilometers beneath the Earth's surface, scientists found microscopic fossils of single-celled plankton that had lived almost 2 billion years ago. It was a moment that defied logic. Fossils are usually found in sedimentary rocks close to ancient seas, not inside granite formed under crushing heat and pressure where life should have had no trace. Yet, here they were, tiny imprints of life preserved against all odds. What made the discovery even more astonishing was the state of these fossils. Despite being so delicate, they were remarkably intact, aligned in patterns that suggested they had not been randomly swept downward, but had become part of the very rock itself. Their presence forced scientists to reconsider long-held beliefs about Earth's crust. Could it be that once, in the deep past, oceans and seabeds had been drawn into the foundations of continents, carrying life with them? If so, these fossils were not simply remnants of ancient plankton, but witnesses to the planet's restless reshaping. The mystery only deepened with questions of survival. How had these microorganisms, so fragile on the surface, endured for billions of years beneath such harsh conditions? The answer seemed to lie in the protective embrace of impermeable rock layers that sealed them away like a time capsule. Their preservation told a story of Earth's hidden archives, where the boundaries between geology and biology blur in ways still not fully understood. This single discovery transformed the borehole from an engineering marvel into a window into Earth's distant past. Each fossil became a whisper from an ancient ocean, a reminder that life has always found ways to leave its mark, even in places no one thought to look. Far from being a minor curiosity, the fossils deep within granite offered a breathtaking glimpse into the persistence of life and the strange intertwined history of our planet. Superheated frontier. When drilling began, geologists expected the temperatures deep underground to rise steadily, but stay within predictable limits. Based on established geothermal gradients, it was assumed that at a depth of several kilometers, the heat would hover near 100 degrees Celsius. Yet, as the drills carved further downward, the readings shattered these assumptions. Instead of the mild boiling point of water, the instruments recorded staggering temperatures climbing toward 180 degrees Celsius, with some reports estimating closer to 180 degrees. This level of heat was not only a scientific surprise, but also a practical nightmare. Machinery carefully engineered for the project began to fail under the extreme conditions. Drill bits warped, sensors malfunctioned, and lubricants broke down, forcing teams to constantly repair or replace essential equipment. Every additional meter came with rising risks, pushing the technology of the time to its limits. What was supposed to be a controlled descent into Earth's crust turned into a battle against relentless heat. The unexpected temperatures raised profound questions about the dynamics of our planet. If such heat existed at relatively shallow depths, compared to the Earth's overall thickness, what did it suggest about deeper layers? Was the crust thinner in some regions? Or was heat transfer more complex than models had suggested? These inquiries opened new debates in geology, reshaping ideas about thermal flow within the Earth. For scientists, the discovery was both frustrating and fascinating. On one hand, it halted progress, preventing them from reaching the deeper mantle as originally planned. On the other, it revealed a hidden intensity beneath the surface that had never been fully appreciated. Instead of yielding to the drills, the Earth reminded researchers of its raw and untamed power. Rock that behaved like plastic. When the drill pushed deeper than ever before, the the team expected to cut through solid, unyielding layers of ancient stone. Instead, they encountered something that defied all normal expectations. Granite, basalt, and gneiss, rocks usually known for their toughness and rigidity, suddenly lost their familiar strength at such extreme depths. Under the crushing weight of the earth above and the searing heat rising from below, these stones transformed into something entirely different. Rather than splintering or fracturing, they bent and flowed like a softened material, almost as though the earth itself were alive and breathing beneath the drill. At surface level, granite is the kind of rock used to build monuments and withstand centuries of weathering. Basalt, born of volcanic eruptions, is typically so dense and strong it resists breaking even under immense pressure. Gneiss, with its banded patterns, forms the backbone of some of the world's oldest mountain ranges. But far below the crust, these very same rocks behaved in a way no one had truly seen before. They became ductile, stretching and deforming without breaking, as if their entire nature had been rewritten by the environment in which they existed. This strange plastic-like behavior created unexpected challenges for the drilling teams. Instead of being chipped away or crushed, the rock pressed back, slowly closing in around the drill bits. The machinery that was designed to cut through hard stone was nearly useless against a substance that refused to stay still. It wasn't that the rocks were harder than expected, it was that they moved, shifting and squeezing unpredictably. Engineers often described it as though the rock was swallowing their equipment, a living force resisting intrusion. For geologists, this phenomenon unlocked new understanding about Earth's inner dynamics. It explained why tectonic plates could slide past one another and why mountains could rise and fold over millions of years. These rocks, once thought to be rigid, revealed their ability to behave more like a viscous substance under certain conditions. The discovery aligned with theories that sections of the lower crust and upper mantle flow slowly over time, acting as the engine behind earthquakes and continental drift. What made the finding extraordinary was not only the challenge it posed to engineers, but also the validation it gave to scientific predictions. The behavior of granite, basalt, and gneiss under such extremes confirmed that Earth's interior is not frozen in place, but constantly shifting, reshaping the planet from within. Less dense crust left scientists guessing. When Soviet scientists began drilling the Kola super-deep borehole, they believed they were heading into a predictable and solid section of Earth's crust. The project, which eventually reached more than 7 miles below the surface, was meant to uncover secrets of the planet's interior. Yet instead of confirming long-held theories, the borehole revealed surprises that left geologists rethinking what they knew about the ground beneath us. The biggest shock was the crust's unexpected density. For decades, textbooks had described it as heavy, compact, and rock-solid. But as drilling advanced, instruments recorded sections that were far less dense than predicted. This discovery forced scientists to confront the fact that their models of the crust's makeup were incomplete. The borehole had turned into a laboratory, proving that Earth's interior is not as straightforward as once imagined. The field of plate tectonics also had to be reconsidered. If the crust varied so much in density, then continental movement was influenced not only by the giant plates visible at the surface, but also by the hidden structure beneath them. A lighter crust in some regions could shift more readily, while acting as a pathway for water that lubricated tectonic boundaries. This explained why some fault lines were more active and dangerous than others, even when they seemed similar on the surface. At depths where crushing pressure should have eliminated any possibility of liquid, researchers instead found trapped water within porous rock. The borehole revealed that certain layers were not tightly sealed, but riddled with tiny spaces and fractures, creating hidden reservoirs. Such findings challenged assumptions about how water circulates inside the Earth and suggested that vast quantities may be stored deep below, far from the oceans and surface lakes we know. Equally puzzling was the effect on pressure distribution. Scientists had expected pressure to increase evenly with depth, but the lighter crustal zones disrupted this neat pattern. Instead, stress accumulated irregularly, providing insight into why some regions of the planet are more prone to earthquakes or volcanic eruptions. For engineers, the discoveries created constant difficulties. The drill encountered porous and unstable rock where solid layers were expected, causing collapses and equipment failures. Temperatures soared higher than predicted, adding further complications. The less dense crust, the presence of deep water, and the uneven spread of pressure all revealed that Earth is far more complex than models had suggested. What began as a quest for certainty became a reminder that the ground beneath our feet still holds countless secrets, waiting for future explorers to uncover. Clues to unknown chemistry and maybe life. At depths where sunlight never penetrates, pressure is crushing, and temperatures approach levels lethal to most life. Hints of unusual chemistry and perhaps even microbial survival emerged. This discovery sparked worldwide curiosity, as it suggested that the deep Earth might not be entirely sterile, but could instead harbor unique forms of existence. The borehole revealed gases such as hydrogen, helium, nitrogen, and carbon dioxide trapped within rocks, raising the question of whether these compounds were purely chemical in origin or tied to biological activity. Specialists in microbiology speculated about extremophiles, microorganisms adapted to conditions once thought uninhabitable. Thermophiles, for instance, are known to survive in boiling hot springs and hydrothermal vents. At the temperatures recorded in the Kola depths, hyperthermophiles, which thrive at up to 122 degrees Celsius, could in theory exist. Barophiles, also called piezophiles, are microbes that flourish under extreme pressure, such as those found in ocean trenches, and might find similar refuge in the crushing confines of deep rock. What stunned many researchers was the possibility of endoliths, microbes that live inside rocks themselves. These organisms, some of which have already been identified several kilometers underground elsewhere, feed on trace elements and hydrogen released through rock-water reactions. The presence of fossilized plankton in the Kola core samples reinforced the idea that organic matter can be transported downward over geological time, providing at least some of the raw materials for deep microbial ecosystems. If life exists in such a forbidding environment, it would likely depend on chemosynthesis rather than photosynthesis. Instead of relying on sunlight, organisms could extract energy from chemical reactions involving hydrogen, methane, or sulfur compounds. This has enormous implications not only for understanding Earth's hidden biosphere, but also for astrobiology. Worlds such as Mars or Europa, where surface conditions are hostile, may still harbor microbial life beneath their crusts, sustained by similar processes. The Kola Super Deep borehole, initially drilled to probe Earth's structure, ended up offering clues that life may persist in places humans had always assumed were barren. It reminded science that even at the planet's deepest edges, the boundary between chemistry and biology remains blurred. Broken drill bits and project demise. The Kola Super Deep borehole was once a grand scientific vision, but its downfall came from a series of setbacks that slowly drained its momentum. One of the most damaging moments occurred in 1984, when the team faced a catastrophic equipment failure. During routine drilling, a massive section of the drill string, nearly 5 kilometers in length, snapped off inside the borehole. The broken pieces could not be retrieved, leaving the shaft blocked and forcing engineers to redirect the project along a new branch. This event marked the beginning of an uphill struggle that would never be fully overcome. As the hole grew deeper, another challenge became even more pressing. Temperatures far exceeded predictions, reaching over 180 degrees Celsius at depths of 12 kilometers. Such heat warped tools, weakened metal, and made drilling increasingly unstable. Every attempt to continue meant greater risks of further breakdowns. The extreme conditions not only slowed progress, but also made it nearly impossible to maintain the precision required for deeper drilling. The original dream of reaching 15 kilometers became more distant with each setback. While technical issues mounted, political and economic pressures added another layer of difficulty. The Soviet Union's collapse in the early 1990s caused funding streams to vanish almost overnight. What had once been a flagship project of national pride suddenly became a costly burden in a country struggling with widespread economic hardship. Equipment upgrades were postponed, maintenance was neglected, and staff numbers dwindled. Without consistent financial support, even the most skilled engineers could not push the borehole further. By the mid-1990s, enthusiasm for the endeavor had faded. The project had revealed groundbreaking data about Earth's crust, but its practical future looked grim. Each attempt to drill deeper ended in broken machinery, overheated equipment, or exhausted budgets. The once ambitious target of 15 kilometers was quietly abandoned, and the borehole never extended beyond 12 kilometers. Eventually, the site was left to deteriorate. Rusted towers, abandoned buildings, and sealed shafts became symbols of a dream that outpaced both human technology and political stability. What began as a quest to reach Earth's deepest secrets ended instead as a cautionary tale of ambition, fragility, and the limits of human engineering when confronted with the raw power of the planet itself. From scientific marvel to deserted relic. The Kola Super Deep Borehole began as a daring scientific venture, a project that pushed the limits of human knowledge and technology. For decades, it was celebrated as a marvel, offering insights into the composition of the Earth's crust that had never before been possible. Researchers uncovered unexpected rock formations, discovered traces of water kilometers below the surface, and revealed complexities in geology that challenged existing theories. At its height, the borehole represented the Soviet Union's determination to demonstrate both scientific and political strength, a bold attempt to go deeper than any nation had ever gone before. The decline of the borehole mirrors the decline of the surrounding region. Nearby towns such as Nikol and Bulyarny, once alive with workers and their families during the Cold War era, now feel hollow and worn. Population loss, economic struggles, and the fading of Soviet-era industries have left behind a haunting landscape. Streets that once buzzed with activity now stand quiet, with aging buildings and shrinking communities reflecting the passage of time. These towns, like the borehole itself, embody the end of a chapter where ambition was driven as much by geopolitical rivalry as by scientific hunger. Today, visitors who see the sealed shaft and rusted remains are left to reflect on the ambition that created it and the stark reality that ended it. The borehole has shifted from a beacon of scientific progress to a relic of history, silently reminding the world of both the greatness and the fragility of human endeavor. Though the project has ended decades ago, but what if we take a step back and ask, what lasting impact did it leave behind? And what could humanity have uncovered had it actually reached its full depth? Future possibilities of the Kola borehole. If the Kola Super Deep Borehole had continued beyond its closure in the early 1990s, the impacts could have been immense for both science and society. The project was halted not because of a lack of curiosity, but due to extreme technical challenges, funding cuts after the collapse of the Soviet Union, and the overwhelming heat and pressure encountered deep underground. Had those barriers been overcome, the world might today know much more about the planet's inner structure, its resources, and even the conditions that shaped life itself. One of the most significant impacts of continuing the borehole would have been in geology. The discoveries made during its operation already challenged established theories, such as the unexpected presence of water trapped kilometers below the surface and unusual seismic readings. If drilling had gone deeper, it could have provided clearer evidence about how the Earth's crust transitions into the mantle. Such knowledge could have revolutionized our understanding of plate tectonics, earthquakes, and volcanic activity. With more precise information, humanity might have improved its ability to predict devastating natural disasters. The project also had potential implications for energy and natural resources. Deeper drilling might have revealed deposits of minerals or rare elements that could be vital in modern technologies. In addition, the study of deep geothermal conditions could have advanced the use of geothermal energy as a reliable and clean source of power. The borehole's data hinted at extreme heat closer to the surface than expected, raising possibilities for harnessing that heat if technological solutions were developed. If the drilling had continued, it might have laid the foundation for a new era of energy innovation. There is also the biological dimension. Scientists discovered traces of microscopic fossils deep underground, suggesting that life may have once existed in extreme conditions. Going further might have provided stronger evidence of how life began and survived on Earth, and possibly how it could exist on other planets. The lessons from such a project could have guided future exploration missions to Mars or icy moons like Europa, where scientists suspect subsurface oceans may harbor life. As for the future, the borehole itself remains sealed, but the concept behind it is not entirely dead. Advances in technology, including stronger drilling materials, improved cooling systems, and artificial intelligence-driven monitoring, make it more feasible today to revisit what once seemed impossible. Countries such as Japan and Germany have already launched new deep drilling initiatives with the goal of reaching the mantle. These projects are seen as successors to the Kola borehole, carrying forward its unfinished mission with modern tools. While the original site in Russia may stay a relic of the past, the dream it represented continues. If international collaboration and investment come together, deeper drilling could still transform science. The future may hold projects that push past the limits that stopped the Soviet effort, finally answering questions about Earth's inner mysteries. The Kola Super Deep borehole may no longer be active, but its spirit lives on as a symbol of what humanity still hopes to achieve. Which discovery from the Kola Super Deep borehole surprised you most? Share your thoughts in the comments.